Hey guys, it's Zara and welcome to my channel. So for today, we are going to discuss nomenclature and its rules. Nomenclature basically means naming chemicals or compounds. So for today's video, we are going to discuss the nomenclature of ions, binary compounds, and acids. As well as we are going to know the stock and classical naming of some of the special elements. So without further ado, let's get started.
Naming ions. We know that ions can have positive or negative charge. That's why it is important to have a distinction among them. Now, let's name ions with just one charge. Cations. These are ions with positive charge. So for naming cations, we just have to follow this format. The name of the element, then the word ion. Now let's try this example. For this example, we have sodium. And we know that to name this, we have to take its name and add the word ion. So, the nomenclature of sodium is sodium ion. Another example is lithium. So, we take its name and add ion. So, the nomenclature of lithium is lithium ion. Another examples are listed below. Pause the video and try to answer them yourselves. Now let's talk about naming anions. So anions are negatively charged ions, and to name them we have to follow this format. The root of the element, then change its last part to the suffix ide, then the word ion. Let's take a look at this example. Here we have fluorine, a negatively charged element or a nonmetal. We know that to name this, we have to get the root name of the element, which is fluor, and we have to add the suffix ide at the end, hence fluoride. Then we are just going to add the word ion, just like what we did in naming cations. Therefore, the nomenclature of fluorine is fluoride ion. Another example is oxygen. We have to get its root name and add the suffix ide at the end, hence oxide. Then we are just going to add ion. So the nomenclature of oxygen is oxide ion. Other examples are as follow. Try to pause the video and try to answer them yourselves. Now let's move on to the special elements. These elements have more than one charge, so they require special naming when we are to name them, such as copper, which has positive 1 charge and positive 2 charge. Another example is iron, which has positive 2 charge and positive 3 charge. Now, naming these special elements consists of two ways. First is the old naming or the classical naming, where we add the suffix "us" to the special element with lower charge and the suffix "ik" to the one with higher charge. So for copper with positive 1 charge, its classical name is cuprous, and for the copper with positive 2 charge, its classical name is cupric. For iron, we use its Latin name ferrum for naming it. So for iron with positive 2 charge, its classical name is ferrous, and for iron with positive 3 charge, its classical name is ferric. The new naming for these special elements are what we call the stock naming, where we retain the name of the special element and includes its charge number, then the word ion. So for copper, the one with positive 1 charge, its stock name is copper 1 ion, and the copper with positive 2 charge, its stock name is copper 2 ion. The same goes with iron. The one with positive 2 charge is called iron 2 ion, and the one with positive 3 charge is iron 3 ion. Now, try to identify the classical and stock naming of the given special elements. Pause the video and try to answer them yourselves. For gold, we use its Latin name aurum for classical naming. Moving on, let's learn how to name binary compounds or combination of metal and non-metal. For naming binary compounds, we're going to retain the name of the cation element or the positively charged element and the name of the anion element or the negatively charged element. However, for these, we already do not have to put the word ion at the end. Say for example, we have this compound. To name these, we retain the name of the cation, which is lithium, and the anion name of fluorine, which is fluoride. So the name of this compound is lithium fluoride. Another example is this one. Again, we retain the name of the cation, which is beryllium, and the anion name of sulfur, which is sulfide. Hence, the name of this compound is beryllium sulfide. Now it's your turn. Pause the video and name the given binary compounds. Now let's move on to acids. So, acids are chemical compounds that emits hydrogen in liquids. Acids are named based on their anions, the negatively charged ion attached to the hydrogen. For example, we have chloride ion. And for this to become acid, there should be a presence of hydrogen. Further, in naming acids, there are some key points to remember. In simple acids, just like the one a while ago, we just have to follow this format. So for this, the name of this acid is hydrochloric acid. Another example is this one. So all we have to do is add the word hydro plus the root word of the element plus ic, then acid. Moving on, note the other two kinds of negative ions are the polyatomic ions that have suffixes of ate and ite. These are ions that have distinct names, and they also require specific naming formats when they become acids. First are polyatomic ions with a suffix of ate. With this suffix, we have to follow this format. For example, we have this acid. So, we take the root of this polyatomic ion and add the new suffix ic, then acid. Another example is this one. We take the root of this polyatomic ion and add the new suffix, then acid. Now let's move on to polyatomic ions with a suffix of ite. When these become acids, we have to follow this naming format. For example, we have this chemical formula. So, we take its root and add ous, then acid. Next is this one. So again, we take the root, add ous, then acid. Now it's your turn. That's it for my video. Bye!